Hello class, this is Mr. Bloch, and today we're going to be talking about limit of a function. So, the formal definition of limit of a function is primarily when f of x becomes closer and closer to the number d as x approaches c from the right and the left side. In this scenario, the limit f of x as x approaches c is d. So, formally, this would be written out as limit as x approaches c, f of x is equal to d. So, x from the right side going to c, and x from the left side going to c. Boom, boom, d. So even if this does not exist, if there's a hole at d, we can still have a limit at d because both from the left, x from the left side and x from the right side is going to that number.
I have a question.
Yes.
What if there's a non-existent point and an existent point at c?
Wow, great question. So if there is a non-existent point and there's an existent point, let's say f of x number 2, the limit would still take place at where x from the left side and x from the right side is going to the point. So even though there is a hole at d, that is exactly where the limit would be. Wow, it rhymed. All right, so limit from x to the left side is equal to d, which is also equal to limit from x to c from the positive side f of x is equal to d. Then we have a limit at d.
I have a question.
Yes.
What if the limit is approaching infinity?
Great question. All right. So if the limit is approaching infinity, then we'll have either a solution of negative infinity, infinity, or does not exist. So, how this looks on a graph. Say at C, there is a vertical asymptote. At C does not exist. So from the left side, which is negative, from the positive side, which is positive, x is going towards infinity. And from the right side, x is also going towards infinity. At some point, these two lines will get very close to each other, and we can call that a limit. So since it's going to infinity, the limit of c, as x approaches c, f of x is infinity. All right, same applies if the line is going down, but a common mistake here is that students might see that the bottom is undefined and not go any further. That would be in some cases wrong, because say if limit x is going to c, f of x, which is equal to undefined. So there's a 0 in the denominator. What you would have to do now is you would have to find out where x is going from the left side and where x is going from the right side. These 2 points will take you to an infinity. If x from the positive side is going to infinity and from the negative side is going to negative infinity, then your answer would be does not exist. But you cannot jump to that conclusion. That is where many students will make this mistake. Okay, so we have covered informal and the existence of limits and infinite limits. So, hey, are you ready to do some problems? All right, let's do some problems. So, problem number 1. We'll start off with an easy one because I don't want to scare anyone. Okay, let's just get the gist of it. Problem number 1. limit as x approaches 3, 5x squared minus 8x minus 13 all over x squared minus 5. So looking at this problem, you know that when you plug in c to the denominator, you will not get a 0. So right off the bat, you know this is not undefined. Or you know that this is not undefined. So this is pretty much as easy as it gets. You just have to plug in 3 into all the x's. So down here, this would be equal to, in the denominator, 9 minus 5. Up here, it will be 45 minus 24 minus 13. This equals to 8 over 4, which is equal to 2. So, recapping. As the limit of x goes to 3, that's the x value, the y value will be equal to 2. Okay, so that one was a gimme. If this one shows up on your AP exam or on any of the tests in this class, you are one happy camper. So, okay, let's move on to number 2. This one, I'm just going to throw a little bit of a harder one at you. Okay, so the limit as x approaches 0, x cubed minus 7x squared all over x cubed. Okay, so looking at this, you know that if you put this number into the denominator, you will get an undefined value. So what you have to do is factor. You can do this by taking out an x. So if we take out an x squared minus 7x all over x. You can take out the x, and you're left with this. So you're probably going to tell me, Gabe, what's up? We can still, we're still going to get 0 in the denominator. This is true, but if we plug in a limit with x going to 0 from the negative side, which is a very small negative number. So, let's see. So this squared will be 0.0001 minus another very small number, but it's negative, so it's going to be plus 0.0001 all over x squared, so it's going to be positive 0.0001. This, a very small 0 positive over a very small 0 also positive is going to just be 0. So let's try from the positive side. Limit. So x goes to 0 from the positive side is going to be equal to a positive 0.0001 minus 0.0001 all over 0.0001, because anything squared is positive. So this is just going to get you 0, and that's going to be a very small number, so 0. Your final answer is 0. Cool. So what we have learned from this, we can get 3 different numbers, or 3 different solutions. The 3 solutions will be either a number d, any number d, which just as we found there is 0, which also could be confused as finding an infinity. Some people make that mistake. I don't know why, but I've done it in the past, so don't do that. The next could be a negative infinity or an infinity. Finally, we can have does not exist.